All right, guys, your last quiz you're already done with. You've taken it. I'll grade it. We'll go over your last tests and stuff probably, if not Friday, Monday of next week. We're still trying to get makeups and stuff done. So if you do have a makeup, I do think Miss Corey is going to give an opportunity Friday morning if you're interested in Friday morning to try to get stuff done. But your last test of the quarter is going to be on May 12th. All right, we pushed it back. It's not next week. It's going to be after. So yeah, a little bit of breathing room, especially for those of you who have a bunch of AP stuff going on. This section, we're talking about solving trig equations. So we're going to just solve equations like we normally have done a million times, but now they're just going to have trig functions in them, like the word sine, cosine, tangent, something like that. So you guys are going to need the unit circle. You have to have a copy of the unit circle on these problems. We're not going to make you rewrite it and write it down like that, but we are going to use the unit circle. So let's review a little bit. Some of you forgot about this, and this is where you really messed up on your last test. But if you have an angle that's on the unit circle, what is the sine value? If it's on the unit circle, the sine of the angle is what? X, Y? It's the Y value, okay? Very important. If you are asked to find the cosine and the angle is on the unit circle, all we're talking about are angles that are on the unit circle. What's the cosine value that you would write? X. And then if you're asked to find the tangent, what would you do? You take the Y over the X, okay? You have to remember those trig ratios. So what is the reciprocal of sine? It's 1 over Y, but what's that trig function called? Okay, so CSC, cosecant would be 1 over Y. You would just flip it, right? What is the reciprocal of cosine? Secant. So we would just flip it, but it would be what? 1 over X. And then your reciprocal of tangent is cotangent, which is X over Y, right? If you get those mixed up, you will get every single one of these problems wrong. You have to know those trig ratios. We've been talking about that for a long time now. Now, another thing we need to know is all students take calculus. What does it mean when I say A up here? What does that A stand for? All 6 trig functions are positive. What about when I put an S over here? Sine and its reciprocal, which is cosecant, are positive. Everything else is negative. What about down here when I say T? Tangent and cotangent are positive. Everything else is negative. And then over here, C. Cosine and secant are positive. Everything else is negative, right? Nothing new there. We've done that a million times. Now, this statement, 4 and 5, we are not using. You guys might see that on an SAT or something. When a question says list all the possible angles, are you only allowed to go around the unit circle one time? No. How many times can you spin around the unit circle and find a different angle measurement? Infinite. So that's what this stuff means. If they ask you to list all the possibles, they're saying for sine and cosine, you would put plus 2n pi, which means if you went 2 times around the unit circle, 7 times around the unit circle, you'd end up at the same spot. We are only going to be talking between the interval of 0 and 2 pi. How many times around the unit circle is 0 to 2 pi? 1 time. So you don't have to worry about that. You just might see that. If you are asked, say you solve the equation, just going over some things you might see, and it says cosine x equals the square root of 2, right? So think about this. What value is cosine? X. So look at the unit circle. Is there any x value, any x coordinate that is just the square root of 2? No. So you would have to use a calculator for that. You would have to say cosine. Dylan, do you need to step outside? Okay, so stop, please. You would have to use your calculator for something like that. You're not doing that. So if there is something that is, if you solve and it is not present on the unit circle, then the answer to this would be no solution. So just be aware of that. There actually is a solution for it. It's just not on the unit circle. That'll make a little more sense in a second. Yeah, if you on the test, if you get something that's not on the unit circle, that's it. All right, so let's go through some problems. I went through 8. This is what your problem would look like. If you notice, I went and already put tiny little unit circles so I could just refer to it. But if you were going to solve an equation, how do we solve an equation? Just in general, you isolate what? You isolate the variable, all right? So in this case, we're going to isolate the trig function. Do you see that you have sine x on one side and sine x on the other? Yep. So if we're going to solve, you want to get all the sine x's to one side and numbers to the other, correct? So I'm going to go ahead and just subtract sine of x from both sides. Am I allowed to do that? Yes, we're thinking algebraically. So on the left-hand side, I have the square root of 2. And on the right-hand side, I have what? Negative 2 sine x's. Perfect. Now we're trying to isolate your trig function. Your trig function is right here, sine of x. So what would I do to both sides now? I'm going to divide by what? Negative 2. So I'm going to divide by negative 2. I can hear Mrs. Curtis. I'm going to rewrite it just because I like letters on the left-hand side. So I'm going to rewrite this as the sine of x equals negative square root of 2 over 2. That is not the answer to this question. Your answer is going to be angle measurements. But you now know where to look on the unit circle. What am I looking for when I'm looking on the unit circle for sine values? Y. And I want them to be what? Negative square root of 2 over 2. So where, guys, on my unit circle do I have sine, the y value, is negative square root of 2 over 2? What are the two angle measurements where your y is negative square root of 2 over 2? Talking radians, guys. Okay, right here. Do you guys agree? At 5 pi over 4? And where else? At 7 pi over 4. So your two answers are x equals 5 pi over 4 and 7 pi over 4. And that's it. You guys are going to be provided a unit circle. There's 26 homework problems that are due Friday morning. You guys are always complaining that you want more practice, but then you're like, oh, it's so many problems. This is the practice. You're solving equations. Some of them are going to have squareds. How do you get rid of a squared when you're solving an equation? Take the square root, all right? What do you put in front of your answer if you have a square root? Plus or minus. So instead of having two answers, how many angles are you going to have? 4, all right? It's very simple. All right, anybody have any questions? Again, same thing. What trig function are we talking about? Sine. When we think of sine, what do we think of? Y. Get that in your mind so it works. So I'm going to isolate. I want to get variables on one side, numbers on the other. So I'm going to go ahead and do the same thing. I'm going to subtract sine of x from both sides. So in this case, I have negative square root of 2 equals what? Negative 2 sine of x. And again, guys, if you need to highlight, underline, whatever, you're trying to isolate that trig function. So what are you going to do to both sides? Divide by negative 2. This is where it's really important to be diligent with your signs, not get messy, because the difference between negative and positive is a big deal here. So this ends up saying sine x equals positive square root of 2 over 2, correct? So again, remind yourself, where are you going to look on the unit circle? Where, which, x or y? I'm looking for where the y values are what? Positive square root of 2 over 2. So my y value is positive here, square root of 2 over 2. And where else? Perfect. So your two answers are x equals pi over 4 and 3 pi over 4. Nope. Nope. This is much better than simplifying and verifying. It's kind of a redo of what we've done in the past and then solving equations. So in this case, guys, what is the trig function we're looking at? Tangent, okay? As soon as I see tangent, I think what over what? Okay, y over x. So we need to get that tangent squared all by itself. So there's two things we need to do. What are those two things? We're going to add 1 to both sides. Perfect. So I have 3 tangent squared of x equals 1. And then you said to do what? Divide by 3. Perfect. So tangent squared x equals 1/3. Do I have tangent by itself? I don't have tangent by itself. That says tangent squared. So what do? I'm going to take the square root. When I take the square root of both sides, what goes in front of my answer? Plus or minus. Okay, so let's simplify this. I have tangent of x. What is the square root, guys, of 1? 1. Do we know the square root of 3? No, it's going to stay like that. Hold on. Yeah, go ahead. So can I just leave my answer like that? No, I'm going to have to do what? Rationalize. So really what I'm looking for is where is the tangent of x, positive or negative what? Square root of 3 over 3. So this is where you guys have to do a little bit of math. What I suggest you do, tangent is y over x. What I suggest you do is memorize where the tangents are square root of 3 and where they're square root of 3 over 3. All right, if you look in the first quadrant, obviously it's not here. That's not going to give you square root of 3 over 3. Obviously it's not here, and obviously it's not there, correct? There's only 2 ordered pairs that when you put the y over the x, you're going to get the square root of 3 over 3. And then once you know what it is, then you know where it is in all 4 quadrants. So which one is it? All right, what happens when I take my y value, 1/2, and I multiply it by 2 over square root of 3, right? Because I keep change flip, right, if I divide. So this becomes 1 over the square root of 3, which when I rationalize gives me square root of 3 over 3, correct? So I need all 4 places because it's plus or minus. So where are the 4 places that the ordered pair is x is square root of 3 over 2 and y is 1/2? Pi over 6, 5 pi over 6, 7 pi over 6, and what do you guys notice about all 4 of those denominators? They're the same, okay? You should pay attention to stuff like that. So again, we're going to be, where? Tell me again. Pi over 6, 5 pi over 6, 7 pi over 6. Perfect. And? Great job.
Will they always have the same denominator?
Yeah. Okay, hold on. Number 4. All right, the first thing I look at is the trig function. What trig function we talk about? Sine. When I see sine, I think of what letter? Look at you guys, all right? So look, this is what we're trying to get all by itself. So there's 2 things I need to do. What is it? I'm going to add 3, perfect, and then divide by 4. So I have 4 sine squared x equals 3. Divide both sides by 4. So I have sine squared x equals 3 over 4. So some of you might stop there and be like, well, there's no place on the unit circle as 3/4, so it's no solution. Do I have sine x? No, I have what? Sine squared. How do you get rid of a squared, guys? You take the square root. Perfect. When you take the square root, what do you put in front of your answer? So I have plus or minus. Do we know the square root of 3? No, just leave it under the radical. Do we know the square root of 4? Which is 2. So you're looking on the unit circle for y values that are either positive or negative square root of 2. So I'm going to say, okay, at pi over 3, I hear you, Jaden. Where else? 2 pi over 3. Where else?
4 pi over 3.
Where else?
5 pi over 3.
Perfect. So I'm going to say x equals pi over 3, 2 pi over 3. What was it, 4 and 5? 4 pi over 3 and 5 pi over 3. How we doing? We okay? All right. I'm not going anywhere, Alec. All right, let's look at number 5. What do you guys notice about 5? There's 2 different ones, okay? There's multiplication. There's a lot going on. What do you guys want to do? How would you solve this if these were x's and y's? What would you just thinking? What would you do? Okay, we want to divide cotangent. Okay, we can do that. So if I divide cotangent here and I divide it here. What do you guys have left? You have cosine squared x equals what? Cotangent x. Where did the 2 go? Did you guys divide it out? This is what I would do, all right? If you want to keep doing it that way, that's fine. But guys, what do we do? Let's talk about this for a second. I want you to think algebraically. What do we do when you have different factors and stuff? You know you're going to have to factor something out possibly because something is squared and something is not. What did we do in that situation algebraically? Did you just, or no, we don't have to convert yet. What can we do? Can we move everything to where? Are we allowed to do that? Just move everything to one side, set it equal to 0? If you have something squared, it's probably going to have to factor. So what did you do algebraically? We did that. We moved everything to one side and what? And what? Factored it, right? So I'm going to rewrite this as cotangent x times cosine squared. Whoops. You guys agree this is minus 2 cotangent x equals 0? Now what? What do they have in common? They both have a cotangent, correct? So I'm going to take out cotangent x, cotangent x. So I'm going to factor it out in front here. Cotangent x times, that one crosses off, that crosses off. What are you left with? Cosine squared x minus 2 equals 0. Whenever you have something squared and not, go back to your old factoring rules. Move everything to one side and set it equal to what? 0. Now you guys have factored this. So if this was x times x squared plus 4, whatever, you'd set each piece equal to 0. Look, if this said x times x squared minus 4 equals 0. Now what would you do? You'd set each piece equal to 0, right? Same thing. So I'm going to say, okay, cotangent x equals 0. And I'm going to say cosine squared x minus 2 equals 0. Everybody with me? I'm going to solve the cosine one first. How would you solve this? Okay. Add 2. So you get cosine squared x equals 2. And then what would we do? We're going to take the square root. So what goes in front of your answer? So cosine is what value? X, all right. Where on your unit circle are there x values that are just positive or negative square root of 2? There isn't. So what would you do with this one? This one doesn't work. You could say no solution here. You would only be able to do that with a what? How could you figure out the square root of 2? A calculator. If it's not on the unit circle, this would be plus or minus like 1.4. Nope. Not for this part. For law of sines and cosines, you will. You have to. But if it's not on the unit circle, guys, no solution. So then I'm going to come over here to this one. What is cotangent? X over y. So think about it. You're finding a place on the unit circle that when you take the x and put it over the y, you get the answer of 0. What does that mean for your numerator and your denominator? Where is the 0 going to be? On the top. What happens if it's on the bottom? Becomes undefined. So what you're doing is you're looking on the unit circle for where your x value is what? 0. What would your y value be? 1. At any of the other ones, guys, if it's 1/2 or square root of 3 over 2, you're not going to get 0 as an answer. It's got to be one of the quadrant angles or more of the quadrant angles. So where would that be? Where are the x values? Where are the x values 0? Pi over 2. And 3 pi over 2. Perfect. Finish. Let's go. Let's go to number 6. All right, I have something squared and something not. One's on one side, one's on the other. What should I do? Factor. Not yet. We can't factor right now. We have to put everything on the same side, just like you would if you had just x's. So sine squared x minus 2 sine x equals 0. How would we simplify this? Guys, don't come begging to me for points when, oh, I'm so close to exempting when you're not halfway paying attention. I don't want to hear it. We have 18 days left. You guys got to focus. What do I do here? Okay, we're going to factor out sine of x. So I'm left with sine x minus what? 2. Now what do I do with each piece here? Set each of them equal to 0. So sine x equals 0. And can I just say sine x equals 2? You guys okay with that? I just went ahead and solved it. Okay. So where on the unit circle, guys, am I looking? Y's or x's?
Y's.
I'm looking both for y's because sine is y. Where in the unit circle do you have y values that are 2? You don't. So cross that one off. That's not a valid, it's out of our range. We're just not, it's not on the unit circle. Where do you have y values that are 0? You have it at 2 pi or 0, however you want to say it, and pi. So you can say pi, and then you can either say 0 or 2 pi. That's the same spot.
So when there's no like that number is on the unit circle, do you just want us to put?
You just cross it off. If you wrote no solution underneath that, that's fine. But there is a solution for this problem, which would be this. But if you wrote like here, no solution, just to remind yourself that that doesn't work, that's fine. But you don't have to. If you just cross it off or just realize it's not valid, that's fine. All right, look at number 7. Number 7 and 8 we're going to stop at. If you go on to the next ones, it's just like the problem that was on your quiz yesterday. But what do we notice about this one? They're already on one side. This is just a basic quadratic. Do you both have the same trig function? Sine, right? This is the same thing as saying 2x squared minus x minus 1. Can you factor that? Yeah, what are the factors of negative 2 that multiply to give you negative 2 but add to give you negative 1? What's going to go in the front of each parenthesis? Instead of just x, it's going to be what? Sine x. Good. So what are your two factors? Negative 2 and positive 1. Now, I like to do it this way. If you guys will forget to divide by the a term, you have to do it by grouping. But what do I have to divide both of these numbers by? 2. So this simplifies to sine x minus 1, and this simplifies to 2 sine x plus 1, correct? So now you have two binomials that are equal to 0. What do you do? What do you do with each parenthesis? You set it equal to 0. So sine x minus 1 equals 0. And 2 sine x plus 1 equals 0. So this on the left-hand side would be sine x equals 1. And on the right-hand side, you guys agree this would be sine x equals negative 1/2? Yes? Subtract 1, divide by 2. All right, so in both cases here, we're both talking about sine values. Which sine values? What is sine? X or y? Y. So I'm looking on the unit circle, two different places. First, I'm going to look where all of the y values are 1. Where are the y values 1? Pi over 2, correct. That y value is negative 1. I want it to be just positive. So I have at x equals pi over 2. And then my other one, I'm looking on the unit circle where my y values are negative 1/2. Where are those? 7 pi over 6 and 11 pi over 6. So this one has 3 answers. So 7 pi over 6 and 11 pi over 6. Very good.
So when you factor, the angle does it always have the same denominator?
No, because you're looking at two different places. Like if you notice for where the sine values are negative 1/2, they both have the same denominator. 7 pi over 6, 11 pi over 6. All right, let's do the last one. Again, this is just a factoring problem, guys. This is 2 times 1. What are the factors of positive 2 that multiply to give you positive 2 but add to give you negative 3? Negative 2 and negative 1. So negative 2, negative 1. Since my a term is not 1, I have to divide both factors by the a term. So this ends up being sine x minus 1 equals 0. And sine x minus 1/2 equals 0. What do I do to both sides? I already did. I skipped that step. How do I get sine x by itself? So this is where sine x equals 1. And this is sine x equals what? Positive 1/2. Again, sine is what value? Y. So where on the unit circle, guys? Let's first find positive 1. Where would that be? Okay, so x equals pi over 2. And then on your unit circle, where are your x values? Positive 1/2. Pi over 6 and 5 pi over 6. Perfect. So the next few examples, if you wanted to go on, you're more than welcome to. If you look at 9 and 10, what's the difference of 9 and 10 from what we just did? They're different trig functions. So you'd have to use your identities to convert to which one? The middle one. Yep. Good, good, good. Really simple. We'll finish this tomorrow.